This is Lesson 3, Part 2, Unit 11, Buffers. We're going to be looking some more at calculating buffer pH using the equation pH equals pKa plus log A minus over HA. So our question is, what is the pH of a buffer containing 0.6 moles of CH33N, which we're just going to write as R3N, and 0.95 moles of R3NH in 1.5 liters of solution, and we're given a Kb of 6.5 times 10 to the negative 11th. The beauty of this equation here is we just need a ratio, so we don't need to worry about the molarity because the ratio of molarities will be the same as the ratio of the moles, which simplifies life for us. We need Ka instead of Kb. So we're going to take 1 times 10 to the negative 14th and divide it by 6.5 times 10 to the negative 5th. And that means that our value of Kb is equal to 1.5 times 10 to the negative 10th, and pKb is going to be equal to 9.81. Remember, we take the negative log. So now it's a matter of plugging into the equation. So pH is going to be pKa, 9.81, plus log, and we have to have A minus. A minus is our amine, and HA is our ammonium compound. So we have the log of 0.60 over 0.95, and it's a matter of solving it in your calculator, and when you do so, you get 9.61. All right, let's take a look at the next one. It says, what is the pH of a 1 liter solution containing 1 mole of ammonium chloride and ammonia? This is similar to the one above, so you are going to do it. I want you to pause the video to work the problem and then restart for the answer. Okay, let's take a look at the answer. We needed Ka, so once again we figured that out from determining the value of Kb. There's our value for Kb. pKb is 9.25. We substituted it into the equation, and we ended up with a log of 0.1 over 0.1, and that was 9.25. Notice these are exactly the same value. What we have here is a log of 1 to 1 if we are simply looking at the ratio. Anytime our A minus to HA is equal to 1 over 1, the pH is going to be equal to the pKa. This will become very useful later when we're doing titrations. Okay, let's take a look at the next problem. We're going to look at the pH of a HNO2 solution when the HNO2 is 35% dissociated. So you're looking at that and you're going, huh? What do they mean? So let's take a look at what we have. We have HNO2, okay? And we're going to set up an equilibrium where it's going to dissociate to the H plus ion plus the NO2 minus ion. And it says that the HNO2 is 35% dissociated. That means that 65% of the HNO2 remains, and 35% of it is equal to the moles of NO2 minus because it is dissociating. So now we know the ratio of A minus to HA. And so with that, I would like you to solve the rest of the problem and then restart the video when you're ready. So pause the video to work the problem and then restart for the answers. All right, so going to use the equation pH equals pKa plus log A minus over HA. We know that the pKa has to be equal to the negative log of 4.0 times 10 to the negative fourth. That's 3.40. And we plug that into the equation. pH equals 3.400 log 35 over 65. So these are just, we're using them as the ratio, and it is 3.13.